One. Okay, I guess that's my cue. So welcome. My name is Dr. Jim Lanny. This is a quantitative analysis workshop where you'll be able to follow along with the data that we all upload together, or you can upload your own data. Okay. So with that said, let's just keep going on. So the agenda for today. So first things first, we're going to get some basic building blocks. Essentially, we need to know what levels of measurement are. Okay. How are we measuring a variable? And we need to know what the independent, dependent, and covariate variables are. So those are kind of the basic core things. And I'll just review that quickly because that's could potentially be a stumbling block later. So we want to be able that we know that we have that down. Then we're going to be creating an Intellectus account. I presume folks are starting to do that right now as we speak, or as I speak. Then I will show everyone how we can upload data, either from a sample data set, example data set, or from your own data set, be it Excel or SPSS. Then we'll go through conducting of 7 typical analyses. I'll walk through those analyses, and then we will show you how we download it and edit those results, and then we'll have a final Q&A. All right, with that being said, let's keep sounding forth here. So levels of measurement, there is basically 3 types of levels of measurement of your data: nominal, ordinal, and scale. So nominal, that's Latin for name only. So these are just category names. So it could be fruit in this case, banana, apple, orange. It could be political affiliation, Republican, Democrat, Green. It could be sex, male, female, all the above. So anything is just a category. There's no ordering going on, and it's just a naming of things. Moving on, we next have variables that are ordered in nature. So for example, activity level, it could be sedentary, moderately active, very active. Could be a horse race. Horse comes in first, second, third, fourth. There's an order to the horses coming in to the finish line, but the interval between them doesn't have to be the same. So ordinal data is just ordered data or ranked data. I prefer this movie second, this movie third, but the liking doesn't have to be equal in between those rankings. Scale levels of measurement, and this interval or ratio levels of measurement, but I call it all scale, and in the tool we call it scale. And the example is a thermometer that 10 to 20 degrees is the same distance or interval as from 20 to 30 degrees. And there's lots of things like this, and most numeric data is like this. Age, from age 1 to 2 is the same from 2 to 3. Okay, so we have order and equal intervals in between those levels. All righty. So now let's move on to another, important part, which is, what is an independent variable, a dependent variable, and a covariate?
Before we do that, I like to give them a quick quiz.
Oh, okay.
Measurement.
Excellent. Okay, let's do that.
Okay.
So I want you to have this up in front of them. A level of measurement quiz, select all of the nominal variables. Okay. Political affiliation, temperature, sex, and age. Or select all of the ordinal variables, and then select all of the scale variables. All right. And we're getting real-time results here. All right. I'm very glad we have this.
And don't be shy to answer. We won't know who it is.
We don't know who it is. That is true. What we're trying to do is just educate, not judge. So thank you for that. Okay, so I think it's about stop. And there's a few more, another Okay, well, we're getting there. So, all right, about 80% of you have responded. So nominal is only name and category. So the correct answers were political affiliation because there's no order, right? And sex, male, female. So age, so those have equal intervals between them. So that's more of a scale level variable, and temperature is also equal interval. So, so just heads up. So this is purely a naming, nominal is purely a naming convention that we're doing here. All right. So just political affiliation, or fruit or sex or whatever that is nominal. Okay. Now we go to ordinal. Now we're looking for ordered levels. Okay. First, second, third, but the intervals don't have to be the same. So level of education is right. All right. So level of education, you have an order, but from high school, to associate to bachelor's to doctorate, there may be different years in between or something of this sort. So levels of education ordered, great. Favorite color, favorite color is just a naming convention. So there's no, well, okay. So favorite color, I guess you can go from light to dark, but typically if you had red, blue, green, I'm sure that there's some order within the spectrum. So if that's the case, fine. Activity level, correct. Light, moderate, active. Height, I would not consider ordinal. So it is ordered, right? Someone who's 5 feet is smaller than someone that's 5.5 feet, is smaller than someone that's 6. But the part with height is that there are equal intervals in between. All right. So I would not consider that ordinal, because the next one, the scale, has both order and equal intervals in between. So so in this case, we height would count as a scale, weight, scale, okay, age, scale, ethnicity would not be scale. So these are just categories. So I would just have those be as a nominal level variable. And then temperature, right on. Okay, so good. So that's fantastic. So great job. Most folks got it correct. So it is important as we go through this, because the tool, some of the tests only allow certain levels of measurement. So that's why it's really important to get that. So just think categories, nominal, name only, okay? Like just names. Bob, Sally, Fred, those are just names of things. There's no order to them, okay? Ordered variables or ordinal variables, they have an order, but not equal intervals between them. And then scale is putting it all together. We're naming them 20 degrees. There's an order to it, 21 degrees, 22 degrees, and equal intervals in between. Okay, so terrific. So, all righty. So I'm going to close that down. All right, so let's get to the next kind of basics things. So types of variables. So independent variable, dependent variable, covariate. Those are the three that we want to kind of understand. So an independent variable is a variable that the researcher typically assigns or can change, okay, in the experiment. And it's something that the dependent variable is going to depend upon. So in my example, I said, well, there's different types of fruit, okay, banana, apple, orange, and the dependent variable could be the amount of sugar inside of each of those fruits, okay? So the amount of sugar is dependent upon our independent variable, okay, which is fruit, or it could be, sex or some other grouping variable. The dependent variable is the variable that those scores depend upon, okay, the independent variable. So in my, sugar fruit example, the amount of sugar per fruit, okay, that's our outcome variable or a dependent variable, and that's going to be dependent upon the type of fruit. Okay. And then I'll go back to ask questions. And here is just an example So in this graph, we have, sugar scores, okay? And then we have type of fruit here. The fruit is our independent variable. And our dependent variable is the amount of sugar inside of each of these fruits. These are mock sugar. People who like apples, don't get afraid. It's just for example purposes, doesn't have 25 grams of sugar. So, but just to show you the relationship between dependent variable, sugar in this case, and the independent variable or grouping variable, the categories of fruit. All right. And I'll just go to the covariate. A covariate is a variable that we're really not interested in, but it potentially affects the dependent variable. Okay. So, but we really are not interested in it, but we want to neutralize the effect of that. Okay. So in this example, I said, well, we want to examine, how fast people can run a marathon by sex. Okay, great. But then we notice, hey, gosh, women tend to be younger than the men here. So what we're really interested in is the marathon time by sex. And we're really not interested in age per se, but we want to neutralize that effect. And if in fact age is related or correlated with marathon run times, then we want to use that as a covariate to see that relationship. To neutralize the impact of that. All right, so maybe I'll stop here for a moment and ask if there's any questions about levels of measurement or independent, dependent, and covariate. I know this is a very rough, quick take on it, but the goal was to kind of get to the tool and show you how to do things. And Ms. Moran, you could just share with me if it's okay just to keep going forward. Another example, yeah, got it.
Request for, yeah. Oh, you have it. Another example for okay.
So, again, the covariate is going to be something that's related to the outcome variable. So maybe here in this example, we have our dependent variable. Okay, how much sugar is in individuals on average. There's 15 grams of sugar in a banana, or 25 grams of sugar in an apple when people eat it. But maybe the metabolism rate of different individuals differ. So if we measured their metabolism, that would impact the amount of sugar in their bloodstream. Okay. So I could use metabolism rates, okay, which are correlated to sugar levels in the bloodstream. I could control for metabolism because I'm not really interested in how you metabolize sugar. My interest is in how much sugar is in individuals' bloodstream based on the grouping variable of fruit. So I might use metabolism rates as a covariate to control for that. So I can get to the heart of my question, which is, what's the levels of sugar in individuals eating these different types of fruit? And then someone's asked, how do you control for a covariate? There are different analyses, and that like an ANOVA, okay, that allows you, that knows that you want to control for that variable. So we'll ask you for the DV, it will ask you for the dependent variable, it will ask you for the independent variable, and it will ask you for the covariate. So that's how to kind of get there. One other question about the difference between a covariate and a confounding variable. I think covariates are confounding variables. And there's going to be lots of covariates or confounding variables that you measure and some you don't. So, but I think if the literature has said that, hey, there's some variable that could impact your dependent variable, you may want to consider controlling for that. Okay, all right. So now let's get to the logging in. All right, so I'm going to assume that everyone is logged in, but is that a good assumption or not? So Melissa, we should actually have a poll of how many people are not logged in? Or how many people are logged in? So how should we handle that to make sure that everyone is logged in?
I think we'll give everyone a few minutes to log in. If you are not logged in, if you have questions about that, please put them in the Q&A. We'll also post in the chat the links to log in again.
Very good. And maybe in the meantime, while folks are logging in, based on my 30 years of experience, when students and faculty and businesses come to me, they often have three common problems. So if you're experiencing these problems, you are not alone. And those problems are, I don't know which test to use to examine my research aim or my hypothesis. They don't know the test to use. And we have a tool for that called the decision tree, and I'll share that with you in a moment. Then they don't know how to conduct the particular test. So, and I'll say when we talk about conducting tests, it's also important to realize that we also need to look at some of the assumptions associated with these tests. So the conducting married with the examining the assumptions, and how do we do that in a streamlined fashion? Okay. And then the last part of the puzzle is, how do we interpret that raw output? So what we've done within our Intellectus tool is that we literally have the interpretation of the assumptions and of the output in plain English prose. And then as cream on the cake, we put everything in APA style, tables, figures, references. So, but just to know that, many people get stuck with those questions there. All right. So let's keep going. So now I'm going to switch to the tool. Okay. And I think I can just do that by doing this. Okay, great. So everyone should be logged in and have this screen. All right. So I want to do a couple things. So for folks that have their own data, first of all, if you have Excel or CSV data, nope, that's not the one. So let's just see where that data set is. Got it. Okay. So if you have Excel or CSV, your file should look like this, which is the name of your variable up in the first row, and then the actual data underneath it, be it ordinal or nominal, or be it the numbers, okay? All right. Sometimes in SurveyMonkey or Momentum or Qualtrics, they have several rows of headers, okay? So in this tool, you only need one row of headers, which is the name of the variable. That's it, okay? And that's, again, for CSV or for Excel. Okay. So we can upload data. So for those that want to follow along, you can upload your CSV here, your Excel here, and a lot of folks have SPSS here. This is a standalone tool, so it does not interact with SPSS. Thank goodness. What we have is ways different, but folks do have files. Okay, so you can go to upload data file, and then I will upload a data file just as an example. I'll go to CSV, choose the file. I'm going to go to masterclass and go open, and then upload file. You'll see the levels of measurement. At the moment, you can, here's our friend's levels of measurement. You could just say continue. And then you could do the same whether it was an SPSS file or Excel file or any file. Then we can change these levels of measurement. So, GPA pre and post and sleep, scale, reasonable, fruit, all nominal, movie, I put in 3 movies, Endgame, Godfather, Shawshank Redemption, nominal, although some people may want to rank them. But age group seems like a clear ordinal variable, okay? So here, you could scooch these around if your variables are not in the appropriate order. So these do look like the appropriate order. replace the variables and hit submit. And now that variable's turned into ordinal. Okay, so that is the uploading of data. And if anyone's having difficulty uploading their data, please put that into the chat or into the Q&A, because you're probably not alone and we want everyone to follow along. All righty. For everyone else that does not have data, we're going to get data in using an example data set. So let's just go to choose an example data set. And what we want to do is go to the master class. So you can sort these. Okay. And we want to go to the master class data set and hit select. So give everyone a second to get there. Okay. So we went to example data set. We selected that. I sorted the names. I'm going to master class and then going to select. All right. This is the little description. Create project with this data set. Yes, that's what we want to do. Okay. Here we already have age group is ordinal, movie and fruit is nominal, the other variables is scale. Terrific. And then hit continue. Now we have our data in. Okay, so that's it. So so if you've loaded up your own data, congratulations. If you're following along with the example data set, that's fine too. All right. So there's lots of things to, lots of support here and things of this sort. Let me make this a touch bigger. So I'm going to highlight just one thing because I think it's just that one of those stumbling blocks, which is how do I know which test? So before I go conduct 7 different tests, I want to know which tests. So under the decision tree tab, okay, they'll have different questions about, hey, do I want to, let me hit restart, do I want to, explore differences by groups or predict an outcome or explore relationships or differences over time? And by answering these questions, it's going to drive you to the correct analysis to the right. So I'm going to do the simple example is, hey, I want to predict an outcome like, does the amount of sleep predict GPA, right? Something of this sort. So I want to predict an outcome. Here's our friend's levels of measurement. The GPA is a scale variable, assuming it's a number. Okay. And that drives me to a linear regression. Okay. So I'm predicting an outcome that happens to be scale dependent variable, putting together, or levels of measurement and what type of variable it is, and that's driving us to a linear regression. And what you'll find is that when and I've been asked 5,000 times, what test? And I always say it's based on the research question, okay, how that's phrased, and the levels of measurement. Okay, so I want to predict, right? Based, a scale variable. Okay, so those pieces of information, the phraseology of differences, relationships, or prediction, and the levels of measurement are driving us to this right-hand side here. Okay, so just wanted to take a little sidebar for that. So we have our data set, and I want to now conduct 7 types of analyses. And I want you all at the end of this to be able to conduct at least these 7 types of analyses. Everyone should be able to do this. So because everyone has got data, and if you are unable to upload your data, let me invite you to take a moment, to stop trying to do what you're doing and upload that example data set, upload that masterclass data set so you can follow along. Okay. All right. And if you've uploaded your own data, that's great too. All right, so let's go to the analyses. So let's conduct those 7 types of analyses. And I'll be doing 7 of them, but know that, and I'm doing kind of simple ones, but know that there are very advanced analyses here, like structural equation modeling and mediation. So there's lots of different types of stuff, but I'm going to be doing very basic things. And you can get a lot of information about your data from very simple things. You don't have to do sophisticated things to learn about what is this data telling me. So let's just go to descriptives first. And then you can just select on descriptives. You can see that scroll over. These are support mechanisms put in to help validate your, hey, I'm doing the right thing. I want frequency and percentages and means and standard deviations on my data. Just want to describe my data. So you can select that. And in these dialog boxes, I'll just note that there's options to be had. There's video tutorials to be had. But the simple thing to do is go to add variables, check all, okay, hit confirm. Before I do, look at this. Okay, more clues. This is saying for my descriptive statistics, all these levels of measurement, scale, nominal, and ordinal, are all fine. So just know that that's there. So lots of help along the way, right? So we have videos in there, we have options in there, and we're sharing what kind of variables are acceptable for this particular test. Descriptives. Okay, once we have that, hit calculate. And voila, here is our output. Now, for those that have never been into SPSS or Excel, this is a revelation, okay? Typically, there's raw, uninterpreted output. What we have here is an APA 7 table with a helpful scroll over, and we have auto drafting technology. So I'll just say that here, all the age groups, we have equal sample sizes in each, and it says the most frequently observed category were, all three of these, okay? All right, so each age group had the same. Okay, so just know that there's an auto draft of what's in that table. Ditto for the scale variables. Interval and ratio, we call them scale. Means and standard deviation sitting here, okay? This is sitting in an APA table, okay? And then a draft of that. So now I'm being directed to say, are there questions about descriptive statistics? And I'll download this after I finish all the other tests. I'll download it, show you how to edit it, but I'll just ask the question at the moment if there's questions about running descriptive statistics. And if there's not, that's absolutely fine, and I will sally forth. Okay, so terrific. People get that. Terrific. All right, now let's go to another very common test, which is a chi-square test. A chi-square test is considered a non-parametric test, and I'll go to chi-square, and I'm going to select that data from those variables from my data set. So in this chi-square dialog box, I have to put in variables. Variable 1 is required, variable 2. So here, I'm going to select variable 1. Notice it's only taking ordinal and nominal. Okay. All right, and I'll select variable 2. I'll take movie. So the chi-square test is answering the question, is there a relationship between age group and movie? Maybe younger people prefer different movies than older people. And I would say, is there a relationship between these two variables, age group and movie, or are these really independent from each other? Hence the title, Test of Independence. Also a video. Okay, so let's go to calculate. So for all of these tests, aside from the descriptives, if there's assumptions to be had, they're going to be preloaded. Well, let me start from the beginning. So introduction. They'll always have an introduction, assumptions if they have them, and then the results and appropriate tables. So the introduction, We did a chi-square test to examine whether age group and movies were independent of each other. There were 3 levels of age group. Got it. There were 3 levels of movies: Endgame, Shawshank Redemption, and Godfather. With the chi-square, there are assumptions. Okay, so I'm not going to spend a lot of time on the assumptions, but just know that what we do here is identify the assumptions. Okay, all right. All cells have expected value greater than 0. 80% of the expected values have at least 5. So what we're talking about here is that in this APA table, I have age group here. I have the movies here. You can see in the note that the number outside of those parentheses is what's observed. What's inside is what is expected. Okay. And this calculation is to calculate the expected value. So what this means is that for those under 30, 7 individuals, okay, identified that they liked Endgame. 3 identified that they liked Shawshank. No one liked The Godfather, and so forth. And for this particular cell, this is a cell here, okay, that the expected value of individuals was 3.67. So here we can see that there were more folks that liked Endgame that were under 30 than would be expected by chance. Okay. All right. So the assumptions are looking at these expected values. Okay. And what we do is not only identify the assumptions, but we actually say whether those assumptions were met or violated. So just look at that, what the assumptions are, how they were assessed, and whether they mean it, whether they were violated or not. Okay. So the results of the chi-square. Is movie and age group related, or are these things independent? That's the question. Here we can see that there were significant relationship between movie and age group, and it says so, or significant. This is a way of reporting it. Is the chi-square value 29.45, the p-value, suggesting that age group and movie are related. Again, for those of you who have never seen a statistical package in your life, or those that have, this is very novel to have an interpretation of that significant chi-square value. So in the chi-square test, once we know that these things are related, and it is, again, the value of the chi-square, significance level, anything 0.05 or less, we consider to be statistically significant. Once we know that the model is significant, this chi-square value, and that these things are related, then really we're just drilling into the interpretation, is looking at, hey, which cells, okay, have a higher observed value than we expected by chance, and which cells have observed frequencies that are less than expected by chance. Okay, so here we can see that for those under 30, there were 7 individuals that selected Endgame, which was greater than expected by chance. Here we can see that for those 30 to 50, Shawshank Redemption had more observations than would be expected by chance. And for those that were 51 or older, there were more observations than would be expected by chance. And the contrary for these other ones, right? They had fewer folks endorsing these movies than would be expected by chance. By the way, if you don't get this, don't worry about this. This takes several immersions to get through. So if you get this, great, but know that this is being recorded, and it takes a few rounds, perhaps, to get it into your bones. So if you're not getting it, don't worry about it. You'll get it. We just, we have to start somewhere, and this is where we're starting. Okay, on to the next test. Let's do a Pearson correlation. So correlations, Pearson correlation is under correlations. Pearson correlation is the most common kind of correlation. And here I can look to see if there is a relationship between the hours slept and GPA before some intervention. So that's my simple question. What else is noted in this box? They have to be able to be scale. Okay, good. The video here, and there's other options to be had. So basically we're correlating and we're asking the question, is sleep and GPA related or not? Okay, 4 scale variables. So put in the variables, we hit calculate. Okay, so there's an introduction and we're talking about seeing if there's a relationship between sleep and GPA. The correlations are essentially effect sizes or how important these relationships are. And there's different conventions here for large effect sizes. There's a correlation of a 0.50 and so forth. There's also assumptions that you want things to be linear. And so when we scroll over, what's going on here? So this is indicating what a linear relationship should look like. This is an outlier, not good. And this is curvilinear, U-shaped or some weird shape S going on here. So you want that, one of the assumptions is that you want it to be linear in nature. Okay. Now let's get to the heart of what we're doing here, which is there a relationship between sleep and GPA? We can see, there was a significant positive correlation, new term coming in here, between sleep and GPA, correlation of 0.93. Using those conventions of effect size, that means there's a large effect size. So a positive, so with all of these tests, we also have the interpretation. This suggests that as hours of sleep increases, GPA tends to increase. All right, so that's the interpretation of a positive correlation. We have a couple ways of laying out that table. The matrix would be more useful if we had lots of relationships. For just one relationship, we might just look at that. Okay. Questions about a correlation at all? Okay, so there's a question. I don't see the actual value of the effect size in the interpretation statement. So that correlation coefficient is an effect size. Okay, that is the actual effect size. All right. All right. Okay. And question about, when we correlate these things, which one is the independent and dependent? For the correlations, we're just kind of putting them in, irrespective of whether the IVs or DVs. I mean, we might have some hypothesis that sleep predicts GPA, which we're going to get to, and there is a clear independent and dependent variable. But in correlation, we're just saying, are these things related? Good question. Okay, let's go to the regression. So as it turns out, if things are correlated, they are also predictive of one another. So let's go to that linear regression. Here, you can see the scroll over. Do these things predict a scale variable, scale dependent variable? Here, we can put in the dependent variable, and I'll say I want to predict GPA GPA pre. Okay. And I want to do that by seeing if hours slept predicts that, or average hours slept. So this question, or this research question, or this aim is saying, does sleep predict or impact GPA? And we put in our variables and hit calculate. All right, so we have an introduction, to assess whether sleep significantly predicts GPA. Got it. There's assumptions to be had. One is normality. You can look over this. We've run this quantitative assumption here and interpreted it here. Homoscedasticity is, you can scroll over to see whether your data looks homo or heteroscedatic. There's multicollinearity if you have more than one predictor. There's an outlier analysis if you have outliers. And then we get to the heart of what we're trying to do here, which is, does sleep predict GPA pre? Okay. We have a sweet APA 7 table with helpful scrollovers. And what's happened here? So what's happened here is that we can see that the linear regression, were significant. Okay, this is how to report that F value and the P value and the R square value. Now we're interpreting what that R square value means. What that R square value means is, out of all of the reasons why GPA pre varies, okay, 86.21% of those reasons can be accounted for by sleep in this mock data set. When a model is significant, that is sleep predicting GPA pre, okay, then I want to interpret that beta coefficient. And we do that down below. So we say, well, gosh, the sleep does predict GPA, but how does it predict? What is the impact of this? Well, this is the impact. When we increase sleep by 1 hour on average, GPA pre will increase by 0.55 units. So if you get an extra hour of sleep, you'll increase your GPA by about a half a grade or so. Let's say, all right. So that's the regression, simple regression. Okay. So I'm looking at questions. Okay, so someone's asking about costs. Melissa will email. Well, I guess maybe just go to the website too. Thank you for that. Just go to the website and you can find out about that kind of stuff. The correlations and the assumptions, I have to say that, it's not crystal clear. I mean, as long as it's not looking like those three, I think it's okay to assume that that's linear in nature. You don't see any curvilinear stuff going on. So I don't know if that helps you at all, but I think for me personally, when there's quantitative assumptions, when there's assumptions that can be assessed quantitatively, I like to have a clear number in my brain to say, okay, that p-value is above 0.05, that means that assumption is met, rather than, hey, what does that really mean? That seems a little bit more subjective. Okay, I want to go on to the next test. So let's just do a paired sample t-test. And here, paired sample t-test, I'm going to see if there's differences between GPA pre and GPA post. So maybe there was GPA pre, and then maybe we gave some lecture about how important sleep is, and how important nutrition is, or stress levels. Okay, so maybe there's some intervention, and I want to see, did that intervention work at all? So I can do a paired t-test. And it's paired because for this individual, I'm pairing their score pre with their score post. And for this individual, I'm pairing their score pre and their score post. So hence the term paired t-test or matched t-tests, matched samples t-test. So for a paired t-test, I go to t-test and I go to paired samples. And I will go to variable 1, which is required, and I want GPA pre. I go to variable 2, go to GPA post. You can see these are both scale variables. Hit confirm, put in my variables, great, and then I hit calculate. And here is my paired sample t-test results. Here's an introduction. Here is the normality assumption using the Shapiro-Wilk again. Here that was significant, which indicates that that assumption is violated. And we can talk a little bit about that. what I would say is that there are under the paired t-test, under the, without getting into the weeds that much, I can have it when that assumption is violated, I can enable an automatic non-parametric test. In other words, it would run another test that would accommodate that violation or use a test that does not have that assumption. Okay. The results of the t-test. Results of the t-test was significant. Yay. Okay. We found that GPA at post is greater statistically than GPA at pre. Okay. Sweet APA table, helpful scrollovers, helpful bar plot, and we can see clearly that the GPA at post was higher than the pre, but we have that interpretation sitting inside there. Okay. All right. I don't know which of these questions to go into. Okay. So yeah, we're just going to be doing basics. If you want more sophisticated analyses, well, maybe we'll do another session of these. But at the moment, let's just sally forth because this is capturing what most people are doing. Okay, so I want to go to an independent sample t-test. So an independent sample t-test is examining the question. Okay, are there differences on some scale variable by some independent variable? All right. So, and I think here I think we have it by fruit. Let's see here. So sleep by fruit. So that's the question. Are there differences on hours slept by the fruit that I'm eating before I go to bed? And maybe based on that sugar, maybe I'm sleeping not as much. So let's find out. So I go to t-test again. I go to independent samples, t-test. And I'm going to go to my dependent variable, which is sleep, which is a scale variable. And I'm going to go to my independent variable. By the way, notice the other nominal variables are not showing up. Only the dichotomous variable. In this case, I think it's bananas and apples. So we're answering the question, does sleep differ by fruit consumed? So there's assumptions associated with the t-test. The Shapiro-Wilk is a test that can assess that assumption, that the tool automatically runs it, and then says whether or not that is violated. So in fact, when that p-value is less than 0.05, that indicates that that assumption of normality, okay, that is the scores kind of look like a bell curve, does not look like a bell curve. So that assumption is violated. Homogeneity variance is another assumption, basically assessing whether or not those standard deviations are similar, okay, or homogeneous. And here we can see that that assumption was met. And the results of the test, what do we see just by glancing at the table is that orange seems like the number of hours slept was greater for those eating oranges than for those that were eating apples, was sleeping less. Here we can see there was significant differences, okay, on sleep by fruit. And we have the interpretation here, okay, that our sleep was significantly different between the apple and the orange categories. And here we can see what those differences are. Apple folks slept less than orange folks. And then we have a bar plot. All right. So mine ran and Mann-Whitney t-test as well. Why? Great question. So for simplicity's sake, that's a really good question. So for simplicity's sake, under my t-test, I did not enable my non-parametric test. So, but I can do that. And what that does is when I run that same darn test, I think I just go back here. Let me just go back here and edit our sleep by fruit, calculate. No, I need to run it differently. So let's just go back. So independent t-test, hours slept, great. By fruit, great. Right? Sleep differ by fruit, calculate. So because I enabled the non-parametrics, what that means is that what we've built into the tool is that if one of these assumptions of normality, a quantitative assumption of normality or homogeneity of variance is violated, which because that was significant, that indicates that that assumption is violated. What we also wanted to do was to provide you with the supplemental analysis, which is, hey, guess what? One or more of the assumptions were violated, right? All right. Therefore, we ran the Mann-Whitney t-test, which is also looking at differences on sleep by fruit, okay? But it does not have those assumptions. Okay, that's one piece of it. And then we're looking at the mean rank of hours slept by fruit. So it's a different way of looking at our general question, which is, are there differences on sleep by fruit? And the t-test has assumptions. If they're violated, you can look at the Mann-Whitney. So wonderful question. Thank you for that. And all of these, a lot of these tests do have, if you go to those, as I did, options, they'll have non-parametric, automatic non-parametrics. I disabled those just for simplicity's sake, but great question. By the way, when you have the independent t-test and the Mann-Whitney, you know, you're getting a, no pun intended, you're getting a flavor of the data, right? Hey, gosh, does sleep differ by fruit? And we're doing the t-test and we're looking at the mean differences, right? Right here and here. We're running the Mann-Whitney. We're also seeing that there's differences there. You know, we're getting a picture of, is there differences on it, on sleep by fruit? So it's starting to tell the story, which is what this whole game is about. We're trying to understand things. We want to be able to make claims about things, and we want reliable and valid ways of assessing that claims. So as opposed to people just making up random opinions, right? Let's say, I think that apples have more sugar than orange. We're able to test these, you know, measure these variables, test these variables in this fashion. And that's what we're trying to do here. Okay. All right, so let's go to the maybe a final analysis, which is an ANOVA. And here we can look to see if there are differences on GPA pre. Okay. And we'll look at it by age group. You can see the levels of measurement here. Hit calculate. Here, as in the other tests, we have an introduction. We're looking to see if there's differences in GPA by age. Great. There's assumptions of normality. It's ran and interpreted. Homogeneity of variance. It's ran and interpreted. Great. We have an outlier analysis. And we have our results, which were, or are, the results in ANOVA were significant. Yippee skippy. That there were differences in GPA by age groups. Question is where, which age groups? We have an effect size and our APA table. And for those that have never, or those that have had to make APA tables in the past, this is a real winner because you're not wasting valuable time, you know, formatting your tables. And I'll get there with that download in a moment. And then here is our bar plot. We can see for those under 30, 50 to 30 to 50 and over 50, you know, the mean group of GPA. All right. You can see what's happening here. So it looks like as you're getting older, GPA is greater. And in the table, you can also see those means of GPAs are increasing as you get older, standard deviations and sample size. The ANOVA is looking at overall are the differences on GPA by age group. But what we really want to know is which group differs from which other group. And if you read through this, what you'll find is that under 30 had a statistically lower GPA than those that were 30 to 50 and lower than 50 to 51, and that those in the 30 to 50 age group had lower GPAs than those in the 51 and older group. And that's what that says. And you can just read over that. So, yeah, I'm going to try to stay focused, but I'll answer some of these other questions in a bit. Okay, got it. So, okay, so we've conducted lots of tests here. By the way, lots of dissertations and theses are doing just this. Okay, in an hour, we're knocking out what typically takes 2 weeks or a month, for gosh sakes. So, particularly when we download that document. So, let's see what that downloaded document looks like. Okay, so this is enable. I'll make this bigger. And I'll make this bigger. So here are the tests that were conducted. And I know I ran a few of these. Again, you can hyperlink to these things and get to them. Okay. I'm just going to delete that for the moment. Here's our results. Okay. Here's our descriptive statistics. Okay. Here's our chi-square test. Okay. And so forth. You'll notice all these table numbers and figure numbers are all aligned. So you not have to go through and start numbering these suckers. So just to know that that's in order. Okay. And go through, these are the things that we've talked about already. Going through the ANOVA. Okay. Then we have, for all of the in-text citations, we have APA style references that you can simply go enter, and you have references in APA style. Okay. All righty. We've also included a glossary. This is a curated glossary of all the terms and symbols for each of the tests that were conducted. So when you say, well, I don't know what that min equals. Well, it's the sample minimum. Okay, the smallest value in a given sample. That is one individual. This is their lowest score out of everybody. Okay, or the highest score. So you can use the glossary. It's just to kind of tune up. Okay. All right. So that's all set in there. So editing of this. So, you know, we really had the goal at Intellectus of making the analysis simple, tables and figures simple, accurate interpretation and rigor included. And we also had the goal that you understand that, right? We want to simplify things, but we want to make sure that you get it. Therefore, lots of things are templatized. Everyone who ran this chi-square, this phrase right here, okay, is published with Turnitin. Okay, you do not want to be putting big quotation marks around this thing. So you have to put this in your own voice. So you have to read through this thing and put that in your own voice, or better yet, the whole thing here. Okay. Ditto with these other kind of particularly introductions and assumptions. Okay. This thing is published with Turnitin. So you have to put that in your own voice. All right. So, and I know, you know, some of the feedback is, hey, gosh, there's only so many ways to phrase these things. I get that. Nevertheless, you have to say, you know, if I was writing up the results, the correlation was significant. You know, what would I say here? The correlation to RI sorry, it's going to be painful to watch me type, but the correlation between sleep and GPA was statistically significant. Okay, and then maybe I would put the this business here, and I might do something like this. Okay, you know, R equals whatever this is, 0.93, P less than 0.01, maybe dump this, okay, and then put the interpretation. Okay. This correlation suggests, this correlation means, okay, that as sleep increases, GPA increases. Okay, something like this. Okay. All right, and then maybe put one of the tables or the other. Okay, maybe I would keep at the moment, maybe keep table, you know, table 5 or some darn thing. Okay, something like that. So just to know that, and it's very easy to spot this. Okay, so this is always that way. Okay, that is always going to be templatized. So just know that you should put it in your own voice. Okay, I think this ends the formal part of the presentation. And I think what we're going to do now is open it up to others to ask questions. So this is the Q&A part. And see here from current slide. So maybe we'll just stop here for a moment. And Melissa, feel free to jump in. Or anyone else and to ask questions, and I'll look at them.
We've had a couple people ask about effect size, so if you can go over that again, I think that would be helpful.
Yeah, so effect sizes are important in a couple of ways. Effect sizes in the context of what we've been doing here really answers the question of how important is this relationship? So if we look at the Chi correlation, for example, you know, this correlation coefficient is an effect size, and it speaks to how important that relationship is. So, and relationships are, as this introduction suggests, is that, you know, relationships or the importance can be considered, you know, small or moderate or large, you know, or really important. So I think that's the way that I think about them. I'm sure there's more sophisticated answers, but the effect sizes talks about the importance of relationships or importance of differences. As it turns out, if you have very large samples, small, tiny differences can be significant, right? If you take 1 million people and say, is there a difference between height between men and women or some darn thing? Give a small difference, can be statistically significant, but not an important difference. So that's getting, the effect size is getting to the importance of that. And again, I'm sure there's more sophisticated answers, but that's how I think about it. Other questions?
Just quickly, we've had a lot of people ask if we can send them this Word document that you created. So yeah, we can send that, we'll send that out with the recording.
Be happy to. Interesting. Okay. Yep. I will not delete that. Okay.
Yeah.
Other questions? Anything at all?
Power analysis, we've had a few about those, or about that.
Yeah. So there are what did we assume here? What we assumed is we had data and that we had research questions in our mind, right? So you need to have the research questions, and the decision tree is going to help you figure out what test. That's important. The data plans, once I know I'm doing a t-test, okay, you know, when you're preparing your study, you know, for IRB and in your methodology section, you're going to need to know what are the assumptions of these things. So, you know, the data plans have templatized, you know, what the assumptions are. So you can download and edit this document to figure out the assumptions. So we know the test, we know the assumptions of the test, but the third part of that plan is how many individuals do we need? So, I mean, intuitively, we know that we need more than 2, we can't get 1,000. So the power analysis is a sample size calculation based on the test. So what that means is that, and this kind of dovetails with this effect size business. So the power analysis helps you determine what the sample size is. So for a paired t-test, there's different sample size calculations based on the effect size, okay? So I'm doing a paired t-test. I want to say, hey, did my intervention about sleep and nutrition make a difference between GPA pre and GPA post? Okay, great. I'm going to do a paired t-test. How many participants do I need? Well, you know, there is a theoretical and a practical answer to that, okay? The theoretical answer is based on the effect size, that is, hey, other people have looked at GPA pre and post and have seen the effect sizes. That is it easy to detect differences? That would be a large effect. It's easy to detect that. Hey, there's an effect, but it's really tiny. It's hard to see differences in GPA, the small effect based on the literature. So that's how one might select effect size. There's also a practical implication. That is to say, guess what? I cannot get 199 people, or for ANOVAs, right? Just look at this. You know, hey, I'm looking. You know, I'm looking to do an ANOVA with 2 groups. You know, for those variables, I've noted in the literature that it's a small effect on GPA by groups or something of this sort. So, but there's no way I can get that. So there's a balance between what is theoretically expected or desired and what is practical, that most students or faculty do not have the resources or the time to get 787 people. So just to know that we do have a power analysis to help determine the sample size. Okay. Since we're on this, I guess I should say there's consulting sessions, just to know that that's out there in the world. Okay. There are built-in video libraries, just to know that that's out there in the world. That's a small fee, that's free. Reference manual, that's free. There's courses to be had. Hey, I'm going to be doing some ANOVAs, just to know there's different courses to be had. That's out there. So courses, free reference manual, free videos. There's different help menus to be had. And okay, go back to other questions.
We had a question about qualitative analysis.
That's
coming soon.
Well, there's a qualitative tool that will be out in a month, and a qualitative course that will be out in a month. So we have some really wonderful things coming out with this. What kind of wonderful things are coming out with this? Well, we will have a feature where you can transcribe your document, your audio in the tool. We will have simple ways for you to upload transcripts, okay, to code and thematize and name your themes. We will have a AI feature which will help you name and thematize and name and describe your theme. And we're going to have a reliability piece that will act as another rater to it, all included in the tool, and have a wonderful course that accompanies this. So stay tuned. If you know other qual people, send them along. Intellectus Qualitative is on the cusp of being released. So thank you for that question.
We had another question. Okay, a lot of people are asking about the cost and subscriptions. Ashley will handle all of that, and I will put her email address in the chat so everyone has it. Please feel free to reach out to her directly. Someone asked how to deal with outliers.
Very specific questions.
Okay.
You know, there was a outliers can impact and do impact correlations and regressions, but it's a tricky question because if it's a real person that happens to be 99 that's in the sample, do we want to throw them out? Or, you know, and there's a whole ethical thing of, did that outlier help support my hypothesis or not? So there's a lot to it. The general rule of thumb is, you know, if I had a large sample, like over 50, and everyone is in this 1 to 5 range, and I got somebody who's out here as a 25, I'm probably going to dump that person. If they're, you know, so it's a nuanced question. I don't have a quick answer for you, but you know, if you had very small sample, well, which is even worse, you have a small sample and an outlier, yuck. Try to get a reasonable sample size by doing a power analysis first, and then consider whether or not that's a real person that should be entered into it. It also has implications for generalizability, right? So if I'm trying to generalize the differences in, you know, sugar in your bloodstream by fruit eaten for this group, and then I have this one person that's 99, maybe I kick that person out and say, gosh, I can only generalize now to the sample of between 20 and 50. Okay. I don't know if I did a good job in answering that, but it's a nuanced question.
Another one is about empty cells, or I think missing data. So we want to make sure that we.
Yeah. So this is another nuanced question. So,
well, and while you get there, it's important for everyone to know you don't want to put in NA or anything like that.
That's
right.
Make
sure that's clear as well.
Yeah. So that's true. No, you know, there's a lot of weird conventions that have happened in the past. You put in NA or -999 or whatever. You know, if it's blank, it should just be blank. So if I was looking for, if I had, let me just do this. So if let's do this. If I was doing, you know, GPA, 6 months, and GPA, 1 year, some darn thing like this. And I had GPAs in here, or this person was and this person was missing someone, right? So just to give an example of missing data. So if this person was missing, first of all, if this person was missing everything on GPA, I would not just impute data there. I would just literally, if they were missing all of them, okay, I would just leave that person out of this analysis. If on the contrary, if they were just missing one and you had, a 10-item satisfaction scale and I just missed one item, and God, I had small sample size, I don't want to lose that person. I might want to impute the mean of GPA 1. So conduct descriptives, get the mean of GPA 1 and impute that to say, hey, you know what, this is whatever this is, 10 by 3, this is, 3.33, something like that. So I might want to impute that if they were missing one out of a whole bank of them. Again, it's a very nuanced question. Other questions?
We've had a few questions about other analyses, and we aren't going to have time for that today, but you all will have access to this tool through the end of the day, through the link provided. If you can pull up the example data sets, I think it would be nice to show them where they can pull data for each test.
Perfect. Nice point. So under choose an example data set, I sorted by name or discipline, but you can sort by analysis. So here I can say, well, I'm running an ANOVA in my thing. Well, gosh, you can select that data set. You can see the DV, the IVs, okay, and the covariate, all right, and then create that data set. And that goes for other very sophisticated analyses like exploratory factor analysis or HLM or structural equation modeling, SEM. So or survival. So for all of the different tests, and we basically have everything that folks need. There might be a one-off, which is, you know, rare, but we have thought through and really worked to make sure you have all the correlations, all of the advanced analyses like EFA, cluster, time series, survival, and we have data sets that accompany them so you can get a flavor of how to run those. So that's a great and that is in the example data sets.
And there's also videos in the video tutorials of each analysis. So we walk you through running it, or if you open it in the app, there's videos within the app that you can follow along with too.
Right. So under, you know, advanced, under, you know, EFA, is that video is what we're talking about here. So once you go into that dialog box of that test, you can get a video tutorial there. Other questions? Other questions? So everyone will get have the tool for the day. You have Ashley's email address. You'll get a copy of the report that we ran.
And if there's general questions, you can email info@Intellectus Statistics. It's on that last slide. If you want to go back to the slide.
Yes. So that's a good place to end. So that's right. So right here, and then we'll triage them, whether technical questions, general questions, and so forth. You can come in for that, and then we'll be emailing you other, you know, the video recording, the recording of it and other information as well. Does this seem like a reasonable place to stop?
I think so. We have a lot of thank yous coming in. And thank you all for joining us.
Thank you so much. We really appreciate the opportunity to showcase a tool that really simplifies the process of analyzing data and answering questions. And again, I really, you know, in this day and time, it's really important to have facts and support your arguments and support your claims. So statistical analyses are one way of doing that you can rigorously examine and have support, rather than just saying, I have an opinion about how much sugar is in your bloodstream by fruit or other kinds of things, and really test out, did that intervention work? Are there relationships between different variables, and so forth? So, you know, that's the whole gist of this. I want to be able to make a claim, to tell that data story in a fashion that makes sense and that is replicable, right? So other people can also look at how I measured a variable and assess what we're doing here. So, and I think with that, thank you again, everyone. Thank you, Melissa. Thank everyone for attending, and just have a great weekend.